they have a common denominator, and we get to this point. Again, putting those addition and subtraction parts together, combined, Dalton, so that we can make sure that they are not separated for some reason. Now we have a fraction over a fraction, and we can simplify that by taking the top, x plus 1, over y, and we can multiply that by the reciprocal of the denominator. Okay, because this is, as it is, this reads this divided by this. And to divide fractions, you KFC. So multiplying by the reciprocal. So I'm going to then take y over x minus 1. I am multiplying, so I can take these individual parts here, the y's, and I can reduce those. Can I reduce the x and the x?
No, because it's minus and subtraction.
No, we have addition and subtraction, that's why we grouped it. Now if this was x plus 1, if this bottom one was x plus 1, then I could reduce the x plus 1 with the x plus 1, but that's why we grouped it, so we wouldn't accidentally just take the x's and reduce them. So at this point then it's just x plus 1 over x minus 1. And if you want to put it in parentheses or leave the parentheses off, it doesn't matter in your final answer. Okay? That is as far as we can go on that problem. We took it from a complex form to a basic fraction form. Now they're not all going to be that nice and neat, are they? Never just that easy. We're going to have to, on the top here, get a common denominator. What well-chosen value of 1 could I use in place of the 1 that would have a denominator of x?
X.
So x over x, I could replace the 1 with x over x. Now I can add, I have x plus 1 over x, and I'm going to put that in parentheses, over 7. And 7 as a fraction is 7 over 1. So I want to multiply by the reciprocal, 1/7. So 1 times the quantity of x plus 1 is still just going to be x plus 1. And on bottom I have 7 times x, so 7x. Can I reduce my x's? No, I cannot reduce my x's because the x on top is being added and is a part of that quantity.
Right, so it doesn't matter how you flip them, does it? Or?
Yes, you have to flip the bottom one or you'll end up with an inverted answer. You cannot flip the top one and it'll work out. Does that make sense? Am I answering your question? As long as you flip the bottom one, you're good. All right. Do I need to do anything to the top of this fraction?
No.
This numerator? No. But on the denominator, again, I need to get a well-chosen 1 in this situation, so that's x over x again. So I have 1 over x minus 1 over x. Now I'm going to flip and multiply by the reciprocal of that one, so that's x over x minus 1. I'm going to get that in parentheses. I should have done that before I did that. Will the x's reduce? We can reduce those because they're individual. So I end up with 1 over x minus 1. Simple. My well-chosen 1 on this, better change my color, would just be b over b. What about my denominator on 4? It's over 1. And so I need to make that denominator b. So 1 times b is b, and 4 times b is 4b. That's a plus b in parentheses over b over x plus 4b over b. Now we do our KFC, keep first, a plus b over b. times and flip the second. Can I reduce the b's? Yes. And then I just have a plus b over x plus 4b. Can I reduce the b's? No, because they're within that quantity. We cannot pull one little part out of that quantity. Ooh. Our favorite negative exponents. When we're adding like terms, I like to move everything up to the top like this. But in order to simplify this problem and get rid of the complex fractions, it's going to require me to write it with positive exponents to be able to add. So this is going to be x over a plus y over b all over 1 over x. Any questions on that? I know a lot of you are just writing. I want to make sure that you understand where those came from. Any problems with that? Now, get your common denominator for a and b, and that would be ab plus ab. So we take the first term times a b, so we end up with xb. Take the second term times an a is ya. And then on bottom, you have 1 over x. Combine these. Okay, that's fine. 1 over x. And to clean up some room, let me see if I can move this batch of stuff. Yeah, that's what I want. Well, I have a solution. I'm going to erase it. How about that? Since you're not going to cooperate. All right. Now we're going to take our x plus b plus ya over ab, and times it times x over 1. So we're flipping the bottom one again. X will not reduce with the AB, so I have x, and then parentheses xb plus ya over AB. Could I what? Could you distribute it through and say x squared b plus xya? Yes. I don't know how the book's going to answer that. I'm going to guess they're going to leave it as undistributed, but if you do, you're not going to be wrong as long as you catch whoever's grading it right. All right, that's it. Just in time. Problem set 68, 1 through 30, and this is due Monday. Test Friday. You are going to do it for the next 20 minutes, though. And then you can choose to do it how you want to do it after that. Would you go ahead and write in on the exact same thing on the 4th and 7th hour as you're writing down for your, please?